Hello everyone, today I'm gonna teach you how to implement fast and easily the Kruskal algorithm. Let's dive in. To begin with, what is the Kruskal algorithm? It is a minimum spanning tree algorithm, a minimum way of connecting a weighted, undirected graph without cycles. It finds the edge of the least possible weight that connects any two trees in a forest. You can imagine a node as a tree and a graph as a forest. It is a greedy algorithm, which means it makes the locally optimal choice at each stage with the intent of finding a global optimum. We have n nodes and we stop when we have n-1 edges. Let's now see an example. We have 7 nodes here from A to G, and we create an array and put inside all the edges sorted by their weight, from the lowest to the highest weight. And we have an array, for example, named sorted edges. We start by the lowest one, which is the AG, and then we continue adding the lowest edges. The next one would be the GE with a weight of 2, and then the EF with a weight of 3. If we have to choose between two paths of the same weight, just pick the one you like. For example, now we could also choose the path ED, because it has the same weight as the path EF. Even if we choose another path, later we will end up with the same result. Always remember to avoid cycles with your choice. Then we choose the ED, and then the DG, right? No, remember, we need to avoid cycles, and if we choose the DG, we form a cycle. Continue with edges that don't form a cycle, like the PC in our example, and then the CD. We now have n-1 edges. The tree, which is formed from our red nodes and lines, is our minimum spanning tree. We can now calculate the total edge weight. How can we do that? You can also see it on the graph, that every edge has a weight. We simply add these weights, and we take here in our example the total of 20. Now let's talk about the time complexity of the Kruskal algorithm. The Kruskal algorithm has a time complexity of O edge log A, or equivalently big O edge log A vertex. And to make it more clear, it is just a big O n logarithmus n time complexity. Thank you all for watching.